Hello, everyone. So my session is going to be about managed identities in Azure, and it's going to be a kind of an introductory level talk. So if you haven't heard about managed identities, that's totally fine. You're going to hear about them now. And at the end, also, we're going to go through some more advanced scenarios as well. So if you have used them, there might be something in here for you as well. So my name is Joonas Westlin. I work as a developer/architect at a company called Azure. And as you might be able to tell from the name, we focus on Azure stuff. So we make custom Azure software, pretty much everything on Azure's platform as a service offerings. I'm one of the Azure MVPs of Finland. And there's also my Twitter account and blog address if you're interested in those. So first of all, we're going to kind of look at what problem the managed identities are solving in your apps. So first we'll look at that. And then I'll introduce what managed identities are, what do they do, and where you can use them. Then we're going to look at the demo app, which uses managed identities. You can also check out the source code for that app. And then we're going to look at some more advanced scenarios. And yeah, just keep your questions coming in the YouTube chat, and I'll try to answer them as we go. So our scenario starts with us having a web application. So in this case, we might have deployed our web app on Azure App Service, which is a very common platform as a service offering on Azure for running web applications. And that application needs to connect to an Azure SQL database. This is like the most typical line of business app that you can come up with. It's an app service plus an SQL DB, right? Now, we need a connection string to connect to this database, right? Our app needs to know, first of all, where the database is, and also the credentials used to connect to it. So this implies a username and password. So most commonly with app service, this connection string is stored in the app services configuration tab. Now, the only issue that there is with that is that whoever has access to that app services configuration now by extension has access to that database with those credentials. And also more often than not, those credentials are the server administrator user. So, not fantastic stuff. Now, quite often that code is also stored in a version control system, at least I hope so, like Git. And in some cases, for convenience, that connection string may actually be duplicated in there. So it's stored in version control in like a configuration file. This is most often done for convenience's sake, because it was the easiest choice, right? But again, this is not a very good thing, because now we're extending the amount of people who have access to that database once again, right? And in an extreme case, someone might actually choose to just allow all access to the database with no passwords. Now, I'm not sure if this is actually possible in Azure SQL, but in some database providers, something like this can be possible. And I can kind of see what the developers were thinking at the time. I mean, who's going to find it, right? I mean, who would just somehow guess the address, right? I mean, that would never happen. Like, well, this might happen to you, right? So don't end up in headlines. Don't disable authentication. It's a pretty bad idea, because your database will be found. In fact, there are scanners trying to find them, like as we speak. So yeah, don't do that. So how could we do this better? Well, there is a service in Azure which kind of specializes in storing secrets, and that is Azure Key Vault. So what about we put the connection string there? Okay, that's a good thing. Now it's in Key Vault. We can control who has access to those secrets there. We can do auditing who accessed it as well, which is quite nice. But now, how are we going to load that connection string into our app so we can access the database? Well, we're going to use a key, right? So wait a second. What did Key Vault do for us now there? We just moved one key into Key Vault. Then we added another key, which gives us access to the key vault. So now if someone has access to the configuration, they get access to the key vault, and then they get access to the database. Like, I mean, sure, it's a little bit more tedious, but from a security point of view, nothing's changed, right? So this is something that we call a bootstrapping problem, right? So how to get started, right? And it's one of those problems that you have, like, how are you going to access the secret store in a secure manner without using a key to authenticate? It's not the only issue that there exists with keys. So you need to manage keys, right? So it's a good idea for you to be aware of like where those keys are being used. So for example, if you have an Azure storage account, you'll probably want to know which apps are actually using those access keys in there. So you want to know like, okay, this component here is going to use this primary access key to access these things and so on and so on. And that's not so trivial to do and keep track of them. You may want to rotate your keys. This is, again, done manually is tedious and also easy to forget. Done automatically is fragile and complicated. Might want to revoke access sometimes. You might want to say, okay, I want this app to not have access to the storage account anymore. How do you do that? Well, you regenerate the key, right? Well, if you didn't do the management correctly, then you may have just broken other things as well, which dependent on that key. And yeah, it's in general can be quite a difficult task, actually. So how could we do this better? Well, this is where we get to the main topic, right? So we get to managed identities. So the full title is Managed Identities for Azure Resources. They used to be called Managed Service Identities. I prefer to call them just Managed Identities for short. It's a service that's fully managed by Azure. It gives your apps running in Azure a kind of service account, so to say, that is fully managed by Azure and is represented by as a service principal in your Azure AD tenant, which is managed by Azure. You don't need to manage that at all. And then you can give access to that managed identity by giving that Azure AD app access to resources. It gives you automatic key rotation as well. This is something that's done in the background by managed identities. This is something that you don't have to worry about at all, actually. And I believe last time I checked, they were using certificates in the background, which were valid for 3 months, and they are rotating them at some point during that 3-month period. So within like 1 or 2 months, you get a new key there, actually, which they're using in the background. But this is something that you don't have to worry about at all. It's done automatically. Oftentimes, it's very easy to revoke access to a managed identity. This depends on the service a little bit. So for example, with Azure Storage, it's very, very easy to revoke access to a managed identity. And also it's nearly instantaneous. So when you revoke access, they will lose it almost immediately. And they enable something which I like to call zero credentials development. Basically a state where you have no keys or secrets anywhere in your code or configuration. And we'll get to how that looks like in the demo. So let's go back to our scenario. So here we have our web app, which is trying to access the SQL DB with the connection string in Key Vault and a key to access Key Vault in the app service. So first of all, let's throw away the key and replace it with a managed identity. So after enabling a managed identity on the app service, we can give that app service access in the Key Vault, and then our app, which is running in the app service, can use that identity to get the connection string and connect to the database. However, we can actually go a step further. Because Azure SQL DB is one of the services that supports Azure AD authentication, we can actually throw away that original connection string entirely. We can give the managed identity access to the SQL database and just use that. So now that is a lot better. And this is your public service announcement that this service is very much free. So there's no cost in using it at all. Now, one of the first things that you're going to run into when you start looking into managed identities is these two words, system assigned and user assigned. So there are two types of managed identities. There are system assigned and user assigned identities. So system assigned identities are assigned on a resource like an Azure App Service. Their lifecycle is tied to that resource. And so if you were to delete that app service, the managed identity is also deleted. Deleting the identity also deletes the app in your Azure AD. So it makes cleanup really, really easy. Another property of this is that because the identity is specific to a resource, it allows you to assign permissions per resource. And I tend to prefer system assigned identities over user assigned most of the time, but it is up to you which one you choose. User assigned identities are different in that they are actually a separate resource that you create in Azure. So you create one, and then once it's created, you can assign it to one or more Azure resources. And this is where you get that difference, because you can assign it to multiple resources. Those resources can share an identity, or those resources can also use multiple user assigned identities if you want them to have multiple identities. Now, if we were to delete that app service, of course, it doesn't delete the identity because it's a separate resource. And this is actually a kind of an advantage of user assigned identities. They keep the permissions given to them, even if the resources assigned with the identity are deleted. So this is, if we were to delete that app service with the system assigned identity, we lose all the permissions given to that. So this is one of the advantages of user assigned. So you can use it in Azure in specific places. So if you deploy your apps or processes in one of these services, you can use managed identities to authenticate to services. So app services and functions is a kind of an obvious one. There's also logic apps, VMs, VM scale sets. Stream Analytics has it in preview for a couple outputs. I believe at least blob storage is there. Data Factory pipelines can use managed identities to authenticate to sources. And API management is pretty limited. It can only use them to get TLS certificates from Key Vault. Blueprints can use managed identities for deployments. Container registry tasks can use them, and container instances and Service Fabric as well can use them. Now, one big service, one very popular service, which is missing from here is Azure Kubernetes service. Well, there is some kind of support in AKS for managed identities, but I believe at the moment it is only for resource deployment and as well as pulling container images from Azure Container Registry. So like the containers themselves aren't able to use managed identities yet. And when it gets to that point, I would add it to this slide. But since it isn't really quite there yet, I haven't. You can also check out the link at the bottom of this slide for up-to-date information on where you can use managed identities. Now, if you do enable it, what can you actually use it for, right? So a managed identity enables your app to get Azure AD access tokens for that identity. This is kind of the idea. So we are able to use any service which supports Azure AD authentication, almost any. There's Azure SQL DB, Key Vault, which we already looked at. We also have Data Lake and blob storage and queue storage. Now, table storage and file storage are not yet supported, but I believe they are probably coming at some point as well. And then we also have Azure Service Bus and Event Hubs, as well as analysis services, and the Resource Management API, which is quite an interesting one. So a lot of these use Azure's RBAC system to assign access to the managed identity. Key Vault has their own thing with access policies. SQLDB has their own thing with the SQL access permissions. But Data Lake, Storage, Service Bus, Event Hubs, all of these use Azure roles. Like, so you can go to access control in Azure and assign access there, which is the easiest one from these. Key Vault's not hard either, it's just that it's different. But as a kind of an advanced option, you can also assign a managed identity access to the Microsoft Graph API. So you can give it access to, read users, for example, from there if you need that. So you won't need any kind of client secrets in your app to read user data or calendar data or anything else from that API. And in fact, this does support any API that supports Azure AD authentication, including your APIs. But that is a quite advanced scenario. It does require your API to support app-only access. So there's no user involved because it's a service principle. So it has to support that. So we'll look at that at the end a bit more. Now, it's time for a demo. So I have the URL for the demo app here, actually, which you can also check out. You can check it out at the same time if you want. So it's westlin.in/midemo. And when you open the app, it looks like this. So let me introduce the app real quickly, what this is doing. So this is called Managed Identity File Sharing. And the idea of this is that this is an ASP.NET Core app that's running on Azure App Service that is accessing Azure SQL database as well as Azure Blob Storage using only the managed identity assigned to this app. You can also find a link to the source code from the top navigation. And so it includes authentication, this app. So you can authenticate with your organizational Azure AD account, as I've done here, or you can authenticate with a personal Microsoft account. That's also possible. But if you log in with an organizational account, you can upload files and they'll be visible to anyone else in your organization who logs in as well. Personal accounts, the files are only visible to yourself. Your organization ID is all the same. So if we grab a file from here, I'll just grab this text file from here and upload that. You can see it appears here. And then if I go to my other tab where I have another user logged in and refresh, I can also see that. I can download this. I can delete that blob as well. Yeah, so that's basically like how this app works. It isn't anything groundbreaking, but I wanted to make a demo app that actually does something instead of being kind of a hello world. So it is an actual application. So if I go here to the Azure portal side. Oh, and by the way, Nick or Martin or Chris, are there any questions so far?
There are no people watching online. If you're on YouTube, feel free to ask in the chat, and then we'll forward to Joonas.
Okay. Yeah, thanks, Martin. So this is the app service that's running this app right now. So if you have an app service and you want to enable a managed identity, you do that through this identity tab here. And I did notice that at least in the previous presentation, the window was a bit small. So let's make this a bit bigger. So that should be a little bit nicer to see on the YouTube. And if you go to the identity tab and you're on the system assigned tab here, then the only thing that you need to do to enable a system assigned managed identity is to click this to on and click save. And that's it. It's done. If you're using ARM templates to deploy your resources, it's a single property there that you need to set. It's quite easy. If you wanted to do user assigned, that's another tab here. Now, this is quite an interesting one. I just want to highlight this one. So the last time I was presenting about managed identities in December, this link just popped up that day. So this allows you to actually see a list of Azure RBAC roles that have been assigned to this managed identity. And I didn't know that this was a thing until I did that presentation, and I thought this was kind of cool. So what you can do is you can actually query for all the roles that this managed identity has. Now, the downside of this is that this only shows Azure RBAC roles. So any Azure AD level permissions are not shown, as well as anything that doesn't use Azure RBAC, like Key Vault and SQL. But for example, we've given it access to Azure Storage, so we can actually see that here. It has the blob data contributor role on this resource, which is actually a blob container. So we'll be looking at that in a bit. So after we actually enable this this identity, this ID shows up here. So this ID is the identifier for the so-called enterprise application, or more, or as the engineers know it, a service principal. So you can find it from here. If you go to Azure AD, Enterprise Applications, and change application type to all applications, and then enter the name of your app service. So system-assigned identities always get the name of the resource that they're enabled on. So the name matches this app service. User-assigned identities, you can decide the name yourself. But here is that application. So, or kind of the service principal, service account, whatever you want to call it. Now, this object ID can be necessary for you sometimes. If you need to programmatically assign access to this identity, you will need this ID, not this one. You can ignore this application ID entirely. Now, if we go to the storage account, you can see that there's under here, blob service containers, we have this files container where we are putting all those files uploaded to this service. And if we go here, you can actually also see that the public access level is private, which means that there's no public access. You cannot read those blobs without authentication. If we go here into this blob container and go to access control, we can actually check here also what access this app has. So we can see that it has this role. And what does this role do? Well, it allows our app to read, write, and delete these blobs from here. And so this is quite nice, because you see here what we've done is that we have actually assigned it this role at the container level, the blob container level. So if you were to use storage account access keys, that access would be, global for the whole storage account. You can do anything in there, but now we can actually limit it. So it's only within this blob container. So if we were to create another blob container here, our app doesn't have access to it, actually. You can, of course, assign that role at account level or resource group level or subscription level, same as any other Azure RBAC role. If you want to do that, you can, but the granularity is up to you. And that, I think, is fantastic about this. There's also a role that only allows read operations, which is pretty nice, if you ask me. So storage did it quite well. Service bus is pretty similar to this, actually. But now SQLDB. Yeah, so SQLDB is one of those that requires a little bit more work. We can't just go to the Azure portal and give it access. That's not possible, at least currently. So here is the database, which is actually storing the file names, for example, that are uploaded into that app. And the main thing that you have to do, if you want to assign access to a managed identity, you need to go to the server, the logical server. And then what you need to do is you have to enable the Active Directory admin. Okay, this is important. You have to you can set a group of users or single users here. That's fine, but you have to set it. Okay, and then we can take our favorite tool for connecting to SQL. In this case, I'm using SQL Server Management Studio. And you need to connect using that Azure AD admin. So you go to connect, and when you connect, you select Active Directory, Universal with MFA support, and you log in. Now, once you're connected, you can run a script, something like this. So at the database level, create a user from external provider, and that has to match that app name. So the service principal name in Azure AD. So you have to do it by name here. There is a very hacky way of adding it by ID. It's terrible. I can't even look at that script that does that. So this is the quote unquote easier way. And after that user is created, so you can see it under here under databases users, you can actually grant it accesses like any other SQL user. So you can limit it as much as you want or as little as you want. It's up to you. You can give it roles or grant select access on a specific table or whatever. But yeah, a couple more steps are required to do this. It would be nice if it supported, just the Azure RBAC and, being able to give it like for example, only read access to all the tables or something. That would be enough granularity for most people.
Joonas.
Okay. Any questions? Yeah.
There's a question about what does that mean for elastic pools? Are there no managed identities at a granular level?
Oh, yeah, elastic pools are a good question. I actually haven't used them in quite some time. So I'm going to have to check that out and get back to you on that. Any other questions?
Not right now, so I guess you can continue.
Okay, good. Then I'm just going to show a little bit of code before we jump into the slides. So this is the application that's running over there. So I just want to show you how we are using those Azure SDKs with managed identity. So this is the service that's actually connecting to Azure Blob Storage. And the main thing that we are actually injecting into this service is this Blob service client. And then in our code, we are getting this kind of Blob client and calling functions on it like upload async. Now, so the only thing we do here is to get this Blob client is to construct this Blob path. We get a client to this Blob container, our files container. Then we get a client object for that specific blob that we are trying to access. So this isn't doing a lot of things, actually. This is less than 80 lines of code, this whole thing, and including comments. And it allows uploads, downloads, and deletes. So there's no authentication, no nothing here, right? And then we have our business layer service, which is getting an entity framework core database context, as well as that blob storage service we just looked at. And if we, for example, look at the download, what we are doing is we are getting this single entity from the database. And that I should probably zoom in a little bit. We're checking accesses there, and we are initiating the download using that service. So again, even for entity framework here, there's no authentication here at all. So if we actually go to startup here, so the startup class is in ASP.NET Core is the place where you configure all the components you will use in your app, as the services, as well as your request handling pipeline. But that second one is not important for us now. So when we are configuring our services, here is the important bit. So we are adding the database-related services, and we are adding the storage-related services. And in both of these cases, we are using this default Azure Credential class as their authentication method. So this one comes from the Azure Identity package, which is a part of the new Azure SDKs. It's available actually in addition to .NET. It's available on Python, JavaScript, and Java, I believe. So similar approaches work there as well. So when we add, for example, the database services, we are setting up this connection interceptor that I've chosen to call the Managed Identity Connection Interceptor. And we are adding this interceptor into our entity framework context, basically. So we are saying that use this. And what does that do? Well, this class intercepts this connection opening event. So this event happens before the connection is opened to the database. And in this case, when we are running in Azure, we have to give that connection an access token. So we have to give it an Azure AD access token. And to do that, we have a function here that returns a cached access token if we have one and it's valid. Now, so the thing about this is that if you use SDK services like blob storage, they do caching for you for the tokens in there. So it's not important to think about that. But because we are using the raw token credential access here, we actually have to worry about caching because it does not do caching at the moment. And you should not be hitting the managed identity endpoint a lot because it cannot handle a lot of requests. So what we do is that we just ask this token credential, please give us a token for this scope. And this just defines that we want a token that allows us to access Azure SQL. So you don't specify the database at all. It is just a token for Azure SQL. So it allows you to access any database that this app has been given access to. And then we return that token and we assign it to the SQL connection. And this is the way that the database context is authenticating there in Azure. Locally, we use a local SQL server, so we skip this if statement basically entirely. And as for blob storage, we are adding that here. And we are using these Azure extensions as well here to make it a little bit nicer. So we are saying that, okay, so for all the clients that I configure here, use the same credentials. And if we are running locally, we will use the blob storage emulator. There's also a way for you to use an Azure storage account locally if you want. But this is, in this case, a bit easier. And otherwise, we say add blob service client, and we just tell it where it is. There's no keys, no nothing. It just tells it where it is. And also here the credential is just default Azure credential. We haven't even given it any options and nothing. So it just kind of automatically works.
Joonas, quick question.
Yep.
If you're using, for example, SQL Server Management Studio, can you easily connect to the database using Managed Identity or using another approach?
If you're using Management Studio and you want to connect with a Managed Identity here, I would say that it's probably with Management Studio, it's not going to be possible. I think none of the authentication methods will allow that. I'm pretty sure. No, not really. So you can do service principal based authentication, but only kind of in code or with the SQL CMD. SQL CMD also supports those approaches, but you have to keep in mind here that the managed identity is only available when you run the app in Azure. So the app has to be running within an Azure VM, for example, where the managed identity is enabled. It is not available outside of that environment.
Cool, makes sense, thanks.
Okay, so if we go back to the slides, for some reason my taskbar is showing up there. Okay, well, That's okay. So one thing that you might be wondering there, which actually that question was about a little bit as well, is that how about local development? Like, okay, well, that's all nice and well. I mean, when you run the app in Azure and you have your managed identity, you can connect to that storage account using that managed identity. However, when you run locally in, for example, Visual Studio, well, we don't have a managed identity because we're not running in Azure. So we can't connect, right? However, there are ways. So, well, first of all, if you can run it locally, you can do that, and then you can, add if statements to use those things locally and use the Azure managed identity in Azure. So, like SQL, you can run locally. Storage emulator, you can run locally. Cosmos DB, which we didn't mention, so you can run locally. But then there are services like Search or actually Azure Service Bus, which you cannot run locally. Then you may need to actually deploy an Azure resource. Now, if you do that, then you have to get those access tokens a bit differently, because we cannot use a service identity essentially unless we actually use client credentials, so client ID plus secret or client ID plus a certificate. So then we can get a service identity, but we can use a user identity, which is an interesting idea actually. And it's something that we can actually do because those RBAC roles in Azure, you can assign to users as well. So you can give a user a blob data contributor role on a storage container, and then get an access token for that user locally for your own user and use that instead. And this is kind of where this Azure identity package that I talked about comes in, because it makes this quite a lot easier for you, because you see default Azure Credential does this for you already. So default Azure Credential is kind of like a multiplexer. It attempts different credentials within it, and then once it finds one that works, it just keeps using that every time. So it tries managed identity. It also tries a shared token cache credential, which is a token cache, basically a file in your local file system that is used by many Microsoft developer tools, including Visual Studio. So it can attempt to use that. It can nowadays, in the newest preview version, can also use the AZ CLI. So this is a cross-platform command line interface for managing Azure resources. So if you have it installed and you're logged in to that CLI, then this default Azure credential can actually use that AZ CLI to get access tokens as your user. And you can also use client ID plus secret. That's not part of the default Azure credential, but it is also available in this package as well as client ID plus certificate, if you want to do that. Now, if you do choose to go through these two paths, you have to be very careful with those secrets and certificates, right? So try not to deploy them in version control. There's also username plus password. That's also possible. I wouldn't really recommend that, I suppose. There's also interactive user authentication. So if you want to do that, you want to make a console app that pops the login view, you can do it with this one. And so this library is actually available in .NET and Java and JavaScript and Python at the moment with a slightly similar name. Like for Java, it's available in Maven, and JavaScript is available in NPM, and so on. So when you can, in local development, if you can use default Azure credential, I highly suggest that you do so. Because it makes it quite a lot nicer, because you can use that same credential in Azure as well. So it uses managed identity there and uses your own user account locally. So that works nicely for services like Service Bus and Storage, which use Azure RBAC, as well as Key Vault, which allows you to assign your user there. And also SQL, because you can assign Azure AD users there as well. So that will work as well. But there are cases where that won't work. But we'll get to those in a bit. Now, if you do use the shared token cache, it's a good idea to specify the shared token cache tenant ID to the default Azure credential, or you can use this one environment variable for that. Because if you have many user accounts in your token cache, then well, it won't know which one to use, and it'll just throw an error. And then if necessary, you can also specify the username, though I would say most people probably won't have multiple users in the same tenant, at least I do in some of my tenants, but most people won't. Now, I've noticed that at the moment, local Azure AD accounts work best with this shared token cache. So like a local user in there, so not an external who's been invited there or a Microsoft account. It's supposed to support it as well, but I've found that it varies a bit. And then if you do need service authentication, where one case actually is if you have a custom API, for example, or Microsoft Graph API that you want to call, then most likely you will need a client secret or certificate to do that. It won't work quite as well with the user-based approach. And then just real quick about this one, I have a couple minutes left. And you can also check out these slides later on if you want. So in order to use managed identities against your own APIs, you have to register at least one application permission on that API that the identity then uses. And then you have to use this scope there when you get those tokens. And this is actually how one of those application permissions looks like. At the moment, you have to define these through the manifest in Azure AD app registrations. There's no UI for this. So you can do it through the JSON manually, or you can use PowerShell to add these. Now, in order to actually ask us to assign this permission to a managed identity, well, normally we would go through app registrations, find our client app and say, okay, this client app can do this thing on that API. Well, no, the managed identity is not there, so we can't do that. Well, I know, let's go to the enterprise app or the service principal. There's a permissions tab and everything, right? No. You can only view permissions there. You cannot actually assign them, which is a major downside at the moment of the portal. And that's why I'm also saying that it's a bit of an advanced case. You're kind of straying a little bit outside the typical path that people do. However, this is a fully supported scenario. You are actually just doing a regular application permission assignment on a service principal, the same as any other application permission on any API. How do we do this? How do we do this then? Well, with PowerShell, of course. So with Azure AD PowerShell, you can actually assign permissions to managed identities as well. What you do need to know before you do this is you have to know the object IDs for the managed identity service principal, which you can get from the App Services Identity tab, for example. Then you need to know the target API service principal object ID. So you have to find your API from the enterprise applications and find the object ID. And then lastly, that last one is the ID of that permission that we want to add. And this is something that you have to define earlier when you define that permission. And then you run this one command as an admin in that AAD tenant, and yeah, permission assigned. So you do need to be a global admin, an application admin, or a cloud application admin in order to run this. So lower than that, nope. So a couple takeaways. If you run your apps in Azure, in any of those supported services that I mentioned there, I would seriously recommend you look into it, implementing managed identities there. It allows you to access any service that supports Azure AD authentication in quite a nice and secure way without any secrets anywhere in your code or configuration. And it's entirely free, so you only pay for the work that you do. And use the Azure Identity Library if it's available for your framework and language, because it'll make it a lot easier for you to do all this stuff. Using managed identities, actually, even with raw HTTP calls within the app, is not super hard. The API is pretty simple, and it's also pretty well documented, actually. If you can find the document, that's, of course, the critical thing. And of course, the local development does require some effort. So you need to, you need to assign users, you need to give them permissions, you need to do stuff differently, and there's things that you have to take into consideration there. So lastly, here are the links related to this presentation. So the first one is the presentation slides on SlideShare. So you can find them from Joonas, Joonas, VACD, and the other two links are to the managed identity documentation, and as well as the sample app that I showed.